Alrighty, let's talk about seasons. Alright, so before we talk about seasons, we have to remind ourselves the difference between revolution and rotation. Revolution is how long it takes you to orbit around something once, so a year, and how long it takes us to orbit around our sun once is 365 and a fourth days. That is how long it takes us to revolve. We revolve around the sun, we don't rotate. When we rotate, we talk about days and spinning on an axis. So it takes us about 24 hours to spin around once on our axis, and that would be a day for us. And we rotate from west to east, so the sun appears to rise in the east and set in the west. When you look up at the sky during sunrise, where the sun is rising will be east, and it goes across the sky to the west because of how we spin. So remember that revolving is around the sun, rotation is spinning on our axis. So whenever we are rotating, the reason we have day versus night is because we rotate, because we spin. And whenever we are on the side that is facing the sun, we are having our day. And whenever we're in the Earth's shadow, we are having our night. So we have days and nights because we rotate. We have seasons because we revolve around the sun. Now remember that whenever we're revolving around the sun, we don't revolve in a perfect circle. We orbit in an ellipse, which is a fancy word for an oval. It's almost a circle, but it's just slightly curved, so it's an oval. And because of that, we are constantly at slightly different distances from the sun. However, it's not the distance that causes the seasons, it's the tilt, as we talked about in class. So we're always tilted the same direction, as you can see in this picture. In this diagram, we're tilted towards the right, and we're always tilted 23.5 degrees. Now, because we revolve around the sun in an ellipse, that tilt is either going to be towards, away, or kind of in the middle as compared to the sun. So daylight is another important thing to consider. You'll have probably noticed when we have winter, the days are shorter, and when we have summer, the days are longer. That's because when we are tilted, we're not only getting more direct sunlight, but the sunlight is going to last for a little bit longer, and the longer sunlight or the lower amount of sunlight is one of the reasons why the weather changes. So it also has to do with light. So remember that tilt causes the direct sunlight that gives us more heat energy, but it also allows the sun to be there for a longer or shorter amount of time, which is why we have seasons. So in this diagram here on the left where it says July, we would be up at the top, and we are tilted towards the sun, so again we're getting that direct sunlight, and we're also going to have it for longer. In July, if you look up at the sun in the sky, not that you should, but if you were to look at the sun in the sky, it's going to be a lot higher up than it would be versus if we were in December. So if you look at the December Earth, we're on the left side of that Earth, and the sun is going to appear lower in the sky. The days are going to be shorter, which causes the temperature to drop and for us to have colder weather. And again, with the sunlight, this is how it would be in summer because we're tilted towards the sun. This is how it would be in winter because we are tilted away from the sun. And there's another diagram to illustrate it. Now, if you look at fall and spring here, notice that we're still tilted the 23.5 degrees because we're always tilted that much. However, we're tilted to the side and not towards or away from the sun. Whereas you look at winter, it's obvious that we're tilted away from the sun. If you look at summer, we're tilted towards the sun. But fall and spring are kind of in the middle, which is why fall and spring have about the same average temperature and why they're called the mild or the transition seasons. Winter and summer are the extreme ones, fall and spring are the mild ones because we're not tilted towards or away, we're nice, happy, and in the middle. And some of you have asked me, what months technically count as what seasons, and solstices and equinoxes will answer that question for us. So we have two solstices, and solstices are when you have the most extreme days in terms of hours of sunlight you have. So during the summer solstice, that would be the longest day of the year, and your winter solstice will be the shortest day of the year. And then you have your equinoxes, which is when you have your perfect middle days. So you have your spring or vernal equinox, which is where you have exactly 12 hours of day and 12 hours of night. And then you have your fall equinox or your autumnal equinox, which is, again, where you have exactly 12 hours of day and 12 hours of night. So, and those usually happen around March 21st and September 23rd. And your solstices will either be December 21st or 22nd, and your summer one will be June 20th or 21st. So your solstices and your equinoxes technically mark the beginning of each season. Are kind of like the most extreme part of each season. So again, June 20th, summer solstice, that will be your longest day. And then you will, from this point on, as you go around, so from June 20th to September 22nd, your days will slowly get shorter until you get to 12 hours, because remember, equinoxes are 12 and 12. And then from your September, from your September 22nd to December 21st, your days will slowly get shorter than 12 hours, because December 21st, your winter solstice is when you have your shortest day out of the year. And then from your winter solstice, December 21st to March 20th, you're going from your winter solstice to your spring equinox. So your days will get longer here until they reach the perfect 12 and 12 for the spring. Holy crap, I'm forgetting my words. For your spring equinox. And then from your spring equinox to your summer solstice, your days will get longer and longer than 12 hours. So remember that pattern as we go around. Remember, it's a summer solstice, winter solstice, spring and fall equinox. Those words are kind of hard to say, but it's okay. All right, and some of you have asked me about, like, why do we have different, like, quote, seasons in different places? Technically, scientifically speaking, all places have the technical 4 seasons, right? But you experience those seasons in different ways depending on where exactly you're located. Like, our seasons here in South Carolina are obviously going to be way different than the seasons in Antarctica or Greenland. So, know first that when you are closer to the equator, the more mild and more summery your seasons are going to be. This is because the equator is like right in the middle of Earth, and even though the Earth is tilting, that equator is always going to be in the middle. So when you live at the equator, you are always going to have 12 hours of daylight and 12 hours of nighttime. It's like you're living in a permanent equinox. And because you're living in a permanent equinox, the seasons are going to be very mild. You will basically have summer all year round. This is why if you look at like a map of what kind of environments are in different places, you have all that lush rainforest by the equator. It's because it's always warm there. It's always summer there. And then as you go further to the poles, meaning like the very top of the Earth or the very bottom of the Earth, the more extreme your seasons and your days / nights are going to be. So if we went to the very top of the North Pole, during summer, that pole, if you look back at those diagrams where the light is shaded in, the North Pole, when we're tilted towards the sun, is always in sunlight. So when it's summer in the North Pole, you have 24 hours of light. However, since you're still at the top, that sunlight is always going to be hitting you less directly than it does, say, closer to the equator. So you have summer and you have longer days. However, it's not a very warm summer. It will still be very icy. Versus while the North Pole is tilted towards the sun, if you look at the South Pole, that little pole is always going to be in the darkness. So when you have winter in the South Pole, you will have 24 hours of darkness throughout the winter season. And again, the light hits it the light is like barely hitting it at that point, so you're going to have a very, very cold, sad winter. So this diagram ties it all together. Remember that you go from winter solstice to fall equinox, summer solstice to fall equinox. The closer you are to the equator, you can see it pretty well, you can kind of see it in this diagram. When you are in the North Pole, you are always tilted. You're in the daylight when you're tilted towards the sun, so that's why they have the 24-hour days, but still the really cold summer. When you're by the equator, you're always going to be tilted pretty close to the sun, so you have that eternal summer / equinox thing going on. Remember that it's the tilt that controls everything and not the distance, even though the distance does change. And we're always tilted 23.5 degrees, even though sometimes it's like towards the sun, away from the sun, or like neither. I believe that is it. So.